Hello everyone, thank you for all being here today. My name is Jessica and I have a quick presentation for everyone about thermometer calibration. It shouldn't take more than 10 minutes of your time and I hope you learned something new today, or at least I hope it'll be a good review. So to begin, we'll go over our objectives. We'll go over the importance of calibration, understanding the general thermometer guidelines, recognizing when to calibrate a thermometer, our two calibration methods, and we'll end it with a review and an assessment activity. So why is it important to calibrate our thermometers? We are working with the immune compromised as well as temperature control safety foods. So it's important to keep our food out of the danger zone, which is between 41 degrees and 135 degrees Fahrenheit. We also know that bacteria grows the fastest between 70 degrees and 135 degrees. So we're always keeping an eye on the temperature and we want it to be as accurate as possible. We also are trying to avoid the time and temperature abuse. So again, we want to keep our temperatures accurate. And when we're cooking and reheating and cooling, we're also using our thermometers quite a bit. The general thermometer guidelines include the cleaning procedures. It's simple. We wash them, rinse them, sanitize, air dry, and then put them back in the storage case. I do want to touch a bit more on the storage case because we are probing raw foods a lot as well as probing cooked foods. So it's easy for us to cross-contaminate by accident when we put them back in our cases. What we want to do is make sure we sanitize them with sanitizer or wipe them down with some alcohol wipe pads. We also want to make sure that our thermometers are as accurate as possible within a 2 degrees Fahrenheit or 1 degree Celsius range. And we want to make sure that we're checking temperatures at the thickest part as well as various areas as well to make sure we have an even temperature throughout. So when do we calibrate? Does anyone know? Yep. So we want to calibrate our thermometers when we accidentally drop them on the floor or bump into them. It can mess with the needle indicator head in the inside. And we also want to calibrate our thermometers when we have received deliveries because we are logging those temperatures, and we also want to make sure that the food we receive has been in a good temperature range. And finally, when we expose them to the extreme heat and extreme cold, we want to recalibrate them to make sure that they're always in the right ranges. Another tip is to always calibrate your thermometers before you begin your shift, just to make sure that you're working with the right temperatures all day long. So we do normally work with a bimetallic stem thermometer, and that's the one that you see on the right. What you have is the indicator head with the numbers and the temperatures and the needle. So it normally ranges from 0 degrees to 220 degrees Fahrenheit. Underneath that a little bit, you'll have the calibration nut, which is what we'll use to adjust the temperature, and I'll show you guys how to do that later on. On the case, we have the holding clip, which is good, so we don't actually have to touch it with our hands. That could give us some inaccurate measures. We have the stem underneath, and right below that is the sensing area, and you'll see it that it's right by the dimple on the thermometer. The first method of calibration that we have is the ice point method. So what you do is you find a container that is tall enough to fit your thermometer in, and what you want to do is fill that container with crushed ice. And you use crushed ice because it's easier for the temperatures to even out as you fill it with tap water. And after your container is filled, you'll want to give that a quick stir just to make sure that the temperature is even. And moving on to the next step is you'll take that thermometer out of the case and put it in the holding clip so your hands don't touch it, and you also don't want the thermometer to touch the sides or the bottom of the container as well. So for about 30 seconds, you'll submerge your thermometer in ice water, and you'll see that it comes down relatively quickly for now, and you want it to reach 32 degrees. What you see is an uncalibrated thermometer as it is reaching only about 38, 36 degrees. So what you'll want to do is you'll take a wrench or pliers or whatever tool you have in the kitchen and adjust the calibration nut right underneath the thermometer. But you'll want to do this while it's in the liquid. I have this video holding it up just to see where you'll be doing the calibrating. So just remember you'll want to do this part in the liquid. Moving on to our next method we have is the boiling point method. It's relatively similar to the first. So what you want to do is, again, use that holding clip for your own sake as well, because you're dealing with boiling water. And then when you submerge it, you really want to be sure you're not touching the bottom of the pan or the sides. So you want to have that good in-between area where you're still in that sensing area. And finally, when you submerge it for about 30 seconds as well, you'll want to hit the 212-degree mark. And just a quick review, the two methods that we did today are the boiling point method and the ice point method. So the boiling point method is to grab tap water and boil it in a deep pan, put your thermometer or stem in the water, and adjust the thermometer so it reads 212 degrees. And it is important to note that the boiling point of water varies on elevation. For the ice point method, we will fill a container with crushed ice and water. We will put the thermometer and the probe in the water for about 30 seconds as well, and adjust the thermometer so it reads 32 degrees. And the bimetallic stem thermometer, just to review the parts, we have the indicator head, the calibration nut, the holding clip, the stem, the sensing area, and the dimple. And the cleaning process, to review that real quick, you want to wash, rinse, sanitize, air dry, and return back to the storage case. And when we name a time to recalibrate the thermometer, after dropping or bumping, exposure to extreme temperatures, before deliveries, and before each shift. And why do we want to calibrate? Time when we're dealing with the time temperature of use, temperature control for safety foods, and the cooking, reheating, and cooling. Does anyone have any questions? And the quiz. So we want to name two methods of thermometer calibration. True or false? The tip of the stem or the probe can touch the bottom of a boiling pan. What temperature do you adjust the thermometer after calibrating it in boiling water? And what temperature do you adjust the thermometer in ice water? A, 30 degrees, B, 31 degrees, C, 32 degrees, D, 35 degrees. Using the materials on the table, you see that there's ice, a container, thermometer, and a wrench. Determine if the thermometer needs to be calibrated, and if you do, show your instructor your results. And then finally, name one part of the thermometer. And then thank you for coming today, and thank you for participating. I really enjoyed today's presentation, and I hope you have a lovely day.